Welcome back to Patch Math, where today we are going to multiply another binomial times another binomial for the second video in our multiplying polynomial series. I wanted to go ahead and do this problem because it has multiple variables. We will be getting to a trinomial, so don't worry. If you're looking for that skill, it will be in my next video in this series. In this case, I'm going to dive just right into it. If you need a firmer understanding of the FOIL acronym, please watch the first video in my multiplying polynomial series. We have our first term times our first term. That is 2x times x. 2 times the invisible 1 in front of the x is 2. And the x times x is x squared, where the 2 represents that repeated multiplication of that x there. Keeping on, we multiply the outer terms in this expression. It's the terms on the outside. We have 2x times negative 4y. Now, here's what's cool. The 2 and the negative 4 are going to combine under good old-fashioned multiplication. And in this case, I should not have written a plus sign there because 2 times negative 4 is positive, or excuse me, 2 times negative 4 is negative 8. But here's the thing. We can only multiply like bases. So in this case, x times y stays x times y. It cannot combine any further than that. Looking at the inner term in our expression, that's the inner term of each binomial. In this case, the 3y times the x, we see the same issue. Now we have the 3 times the invisible 1, that is still positive 3. But we have x times y again. They are not like bases. They cannot multiply any further than y times x or x times y. We tend to go in alphabetical order, so x times y. Then we end on our last term in each binomial. We multiply the 3 times the negative 4, and that is negative 12. Then we multiply the y's. Now, again, here, like we did at the very start of this problem, we have like bases. Y and y are like bases. So we can add the invisible 1 exponents. And so we have y times y at 1 plus 1 up there becomes a 2. All right, and then last but not least, we do need to combine like terms. And in this case, even though we have multiple variables, we do have like terms. The negative 8xy has the exact same variables in this case, with the exact same exponents as the positive 3xy, has the exact same variables with exact same exponents. So those two terms combine, the x and y stays the same. And the negative 8 plus 3 turns into negative 5. We just go ahead and bring down our other terms. And quite simply, here is our new polynomial. In this case, it is a multivariable trinomial with degree 2. Thank you so much for your time.